Okay, so you're going to continue Jerry's, Hank's, and Sal's equations with the same types of drawings. Right, make sure you write their equations next to it so that way you can you know what your drawing is representing. For C, which of these expressions is Takashi's? So this is Takashi's drawing up here. You just have to explain which one of these down here represents this one up here. If there are none, then that's fine as well. Or which one do you think is the closest? Okay. Here's 1.4, revisiting distributive property. So we're going to use the pool and the lengths to represent distributive property. How can you use distributive property and commutative properties to show that two expressions are equivalent? Below are diagrams of pools with swimming pool and diving sections. The dimensions are in meters. So this is 30 meters by x meters and 10 meters for this section over here, etc. This is an x length, this is an x length, this is 25. For each pool, what are two different but equivalent expressions for the total area? So what I'm going to do is I'm going to start writing a couple equations. Actually, I'll do pool 1 and pool 2. Pool 1 and pool 2. And then I'll let you do pool 3 and pool 4. So here's pool 1. This is 30 and x. So this section here represents 30x, 30 times x. This section here is 10. And if this is 30, well, this must be 30 also. So this is 30 times 10. This is 300. So I could call the area of this pool 30x plus 300. Right? There you go. Okay, well, another way to think about this is if I were to write this out, and I had 30 times x, and this is 30 times 10, my distributive property would say these two are exactly the same. I could take them out. So I can call this 30 times x plus 10. 30 times x plus 10. Length times width, right? See that? Okay, I'm going to leave this here. It could be a little confusing, but I'll just leave it there. All right, so this one, the same thing. I'm going to call this section x times 25, x times 25, so that's 25x. And this section here is x, which is the same length here, x times x, which is x squared. So I can call that 25x plus x squared. And I could call this, let me erase this, just like I did before, x times 25 and x times x. And since they both have the same thing, I can't take that one because this one only has one. I could take that part out. So that could be, I'll put it over here off the side, x times, and the leftovers would be 25 and x, right? 25 plus x. X times 25 plus x. Okay, so let me scoot this over a little bit so it fits a little better. X times 25 plus x. X times, and this bottom portion here is 25 plus x. 25 plus x. And you can do these bottom two in much the same way. This one might be a little bit trickier, but shouldn't be too much trickier. Okay. Once you're done with this, you're going to work on questions A through E on page 14. Okay, A through E on page 14. It looks like this. It's just distributive property stuff, not too bad. I'm going to quickly go over this one because a lot of people can make mistakes on this one. So if we have x plus 2 times x plus 5 times x plus 5, I'm going to draw this out like they did on the pool. Okay, so here's my pool, okay, and I'm going to call this side x plus 2. I'm going to call this side x plus 5. So the x length is going to be, I don't know, that long. So this is my x length here. My x length here should be about the same amount. So this is about x by x. So I could call this section x times x, right? X squared. And in this section here, 5 by x, or 5x. This section here, x and 2, they cross paths here, 2x, and 5 and 2, they cross paths here, 10. So they're all pluses, they're all positive numbers. I can put them all together, x squared, and then these two are the same. They're both x's. There's 5x's here, 2x's there. All together I call that 7x, and then I have a 10 over here, plus 10. When I taught this in high school, I used to call this my peanut box, because if you circle the two that are the same, they make a peanut. So there's your peanut box. For B, distributive property is going to go the opposite way. Let me pick one here for you. I'll do number 3. Okay, x squared. I'm going to factor this out. X times x plus 3 times x. Well, what do they have in common? Well, this has an x, and let's do that in a different color. This one has an x. This is times x. They both have 1x each. This has an x, this has an x, so they go outside as one item. X on the outside, and on the inside, I have the leftovers. I have that x plus 3. That x plus 3 is left over there in the middle. Okay. The rest of these, I'll let you work through. Make sure you do order of operations here. And I will post some homework for you guys, mostly just distributive property type of stuff, pretty easy stuff. So finish your videos, copy down your notes, complete your homework. Next class, I'll probably have your answer sheet for your test, and you guys can grade your test together in class, because I won't be there. Alrighty guys, don't give the sub a hard time. She will let me know. Thank you.